We are working on 11.5 notes, and we're talking about the measure of central tendency and modified box plot. So the measures of central tendency we typically refer to as the average. And when someone says find the average, a lot of us tend to think the mean. But there are three measures of central tendency. The mean is the sum of all the values of the set divided by the number of values. It can be represented by this X with a bar on top. You have the median, and the median is the middle value or the mean of the middle values when it's in order numerically. So just like the median of the road. So if you have an odd set of numbers, then the median is that middle number. If you have an even set of numbers, you're going to have to find the mean of those two. All right, and the mode is the number that occurs the most. Okay, so you could have no mode, you could have one mode. All right, so example 1, we are just doing one of these because I know you guys know it. Just as a quick review, we want to find the mean, the median, and the mode. So go ahead, let's find the mean first. What should I do to find the mean?
You should put them in order.
I don't need to put them in order to find the mean. So to find the mean, we're going to add them all up. You don't have to show me the work to add them up, but I want to see the total.
Yeah.
So what is it if we add them all up? 5, 6, 7, 8, 12. And how many numbers do we have? So 12 divided by 7 gives me a mean of, hey, we're going to use our calculators, take 12 divided by 7. We should get 1.714. That is your mean. Now, the median, you do have to put them in order to find the median. So in order, we would have the zeros, 2 of them, then my 1, then I have 2 2s, a 3, and a 4. All right, to find the median, we count in 1, 2, 3, 1, 2, 3, and my median is 2. Now, if I had an even set of numbers, like 6 numbers, my median would have been between 1 and 2, which is 1.5. But if we weren't sure, we would add them up and divide by 2. Okay, the mode is the number that occurs the most. Do we have any numbers that occur more than others?
2.
Oh, I just wrote most. What should I be writing?
2 and 0.
Okay, so this is called bimodal. We have 2 modes. 0 is repeated and 2 is repeated. So this, we can have 2 modes. Now, I guess you could have 3 modes, but it depends on how big your data is. But if you have 3 or 4 numbers that have the same amount, then we would say there's no mode. Okay, so mean, median, and mode. The other thing sometimes you're asked for is the range. So let's just throw that in here. What is the range?
This is the number from the smallest to the largest.
Yep, you find the difference from the high. So we would do 4 minus 0, and your range is? 4. Okay, so let me repeat this. How do you show work? When you do the mean, you would show the total and what you divided by. So I'm expecting to see that and then your answer. The median, the work would be putting in order. There is no work for the mode, but the range, you could show what you subtracted. It is always the maximum minus the minimum. So make sure you find the high and the low. Okay, now, something called expected value. And that's probably something different that you might not remember talking about or have not seen. It's about weighted averages. The weighted average of possible outcomes. So you look for the weight for each outcome of its probability. So we are basing what we'd expect from what has already happened. So if you look down here at number 2, the probability of distribution of successful free throws for a practice set is given below. Find the expected number of successes for one set. So number of good free throws, meaning they went in the basket. We got 0 3/20ths of the time. We got 1 3/20ths of the time, 2 1/5 of the time, and 3 1/2 the time. So it says find the expected number of successes for one set. So guys, here's what you do, and I'd want to use a calculator for it. So write this down. So if you're asked for expected value, expected number, you know what to do. You're going to take the value, which is 0, times the probability that it happened. So 3/20ths of the time, we got 0 points or good free throws. One time, we got 3/20ths. So 3/20ths of the time, we got 1 good free throw. Add on to that 2 times, you would got, or twice. So number of good, I'm backwards here. I like to write it the other way. That's why I'm struggling. 1/5 of the time you got 2. 3/20 of the time you got 1. 3/20 of the time you got 0. So I can expect I got 3 of these 1/2 the time. So plus 3 times 1/2. I would normally do the probability times the value. So it's probability times value. So we're going to get a part of each thing here. So type this in the calculator. It's going to take a second. Now, do we need to type in 0 times 3/20? No, because 0 times 3/20 is what? Well, it'd be 0.
Yeah.
So some calculators, when you type this in, you're going to get 2 and 1/20, or 41/20. Does anybody agree with me?
Yeah.
What'd you say? I don't think it's 2.5. So whenever you guys do this, the expected value, it's basically taking a weighted average. We would expect half of the time you're getting 3 good free throws. 1/5 of the time you get 2. So the idea is we would expect about 2.05 good free throws. So if we rounded that, about 2 good free throws. Okay. So that is called the expected value. Based on what we have, we take the low and the high outcomes, we put it together. All right, flip it over. And now we're going to change gears again. So we're sort of doing one of each idea here. We are talking about box and whisker plots, which I know you have seen. Box and whisker. And honestly, there's nothing hard about box and whisker as long as you remember what I'm trying to find. And then it's not mathematically challenging, but you have to be a little bit organized and patient. So it's called 5 key points or 5 number summary. And it starts with the minimum value, ends with the maximum value. You have the 3 quartiles, which splits it up. So quartile 1, quartile 2, which is the median, and quartile 3. So the interquartile range is finding the difference between the 3rd quartile and the 1st quartile. So interquartile range. And we call that the IQR. All right, it's the difference between the 1st and 3rd quartile. So Q3 minus Q1. I think normally you would see it as Q3 like a little 3 minus Q1 a little 1. So let's go ahead and do a 5 number summary and create our box and whisker plot. I'm not going to do anything on the number line, and so I deal with this. So here is the deal. Everything is based off of the median. And what do I need to do in order to find the median? Can I just look at this and count it and find the median and say it's 10?
No, you put them in order.
Okay, I have to put them in order. All right, so put them in order. We've got, what's the smallest number? 4, and then 1 5.
5.
How many 6s? 2?
6.
Well, there's 2 6s.
7.
7.
8. 6, 7.
All right, I would double check that you have all the numbers, you used them correctly. And now that we've got this, let's find the minimum is easy. That's 4, right? The maximum is 10. And then you're going to jump to the median. Now remember, the median is the same as Q2. So what's the median of this data?
7.
Why?
Because it's the middle.
So we have 9 points of data, right? And 7 is my median. So I agree with you. Now, quartile 1 is going to be the median of the lower half of the data. So since we use 7, we throw that out and we find the median of the lower half of the data.
5.5.
Okay, so the median's between these two. Now, I think a lot of you know that it's 5.5 because it's between 5 and 6. But I just need to talk about this. If you're using a calculator like this and you type in 5 plus 6 and hit divide by 2, can you see that? You're going to get the wrong answer. What's your calculator doing?
6 divided by 2.
It's going to divide first and then add on. Is there any reason that your median should be 8 if you're between 5 and 6? Okay. So what I did wrong was the order of operation. So option, just add them, get your answer, and divide by 2. Other option, use parentheses. 5 plus 6. Tell the calculator to add first, then divide. So I need you to be careful entering it. If you're using this calculator, same rules apply, but you could put it in as a fraction. And if you put it in as a fraction, I put it as a mixed number. If I put it, is that better? Okay. If I put it in as a fraction, let me clear that. I would do 5 plus 6 and go down here, put in the 2. But this calculator is going to give me the improper fraction, hit the double arrow, and there is my decimal. Okay? But you need to pay attention to how you're putting this in. Okay, so Q1 is the median of the lower half. That's Q1. Here's Q2. And Q3 is the median of the upper half. And so what is Q3? 8.5. All right, are we good on that? So here is my 5-number summary. Do you see it? 5-number summary. And why I said it's not hard is you're really finding the median and then 2 more medians. Okay, so now we need to graph it. So my low is 4, my high is 10. I'm going to count by ones, but I'm going to show every 2. So do you see what I'm doing? 0, 1, 2, here's 3, here's 4, 5, 6, 7, and then 8, 9, and 10. Oh, no. 8, 9, and 10. Is that better? All right, might as well keep going there. So do you see that everything represents 1 unit? And then your box and whisker plots are typically put above.
Yeah, I don't know where you're learning
All right,
mistakes from.
number,
You need to get off the internet.
the minimum is 4, the maximum is 10, and then we just put points there, and then we put lines at the 3 quartiles. So quartile 1 is 5.5. I'm going to put a line there. Quartile 2 is 7. I'm going to put a line there. And quartile 3 is 8.5. Remember, that's 9, so 8.5 is here. I'm going to draw my box, and then this is the whisker part. Yes, this is called a box and whisker. Now, I need you to understand a couple things about a box and whisker plot. Each quartile represents 25% of the data. So if you look, these are pretty similar in size, but sometimes one of your whiskers might extend out here. It doesn't matter how long or how short something is, how small the box is. Each part of this represents 25% of the data. So I need you to think about this. We split our data in half. So that was 50 and 50% of the data, right? So 50% of the data is below quartile 2. 50% of the data is above quartile 2. 50% of the data is between these quartiles. Because every chunk here, look, I have 2 pieces of data in each piece. So we split it in half, and we split the halves in half. So the whisker represents 25%. Each box represents 25% of the data. So I can come in and say about what percentage of the data is less than 8.5. Well, here's 8.5, 75%. So you should be able to answer questions about that. Now, why would one whisker be way up here? Well, let's say that the max number was 12. That's just because there's a greater range. So it still has 25% of the data, but the numbers are more spread out. Okay, what is the IQR? The inner quartile range. And that means you're going to take Q3 minus Q1. So Q3 was 8.5. What was Q1? 5.5. And you're telling me inner quartile range is? 3. So 50% of the data was within 3 units of itself. Okay, now you are going to start this next one. Now, what's nice about this next one, there are a bunch of numbers, but they're in what? They're already in order. So take a second. I want you to find the 5-number summary, but don't graph it yet because we're going to do one more extension and find the outlier. So you find me the 5-number summary right now. All right, so I've said it. It's really important that this is in order. If not, we would have had some work to do. But because these numbers, it's nice that it's in order. The minimum is 10.2. The maximum, 16.4. Now, I need to find and the median. So some people just sort of take their fingers and count in. There should be an odd number of data. Do we agree that the median's 14.6? Did we count into that? Okay. Now, I normally like to box it because that number is not being used after this. So the median is the same as Q2, and it's 14.6. Okay. If it was an even set of data, we would just split the data and keep all the numbers. Now, to find Q1, we're going to find the median of the lower half. That's how we're going to find Q1. So this is Q2. What was your median of the lower half? It was another set of odd. Yeah, it was another set of odd numbers, right? So that is the median of the lower half, 14.4. And then we should have 7 numbers above. And did you get the median of this? Is Q3, and you said 14.9. Now, before I graph it, we're going to go one step further, and we're going to look for any outliers. Okay, outliers are numbers that are too big or too small, that don't fit with the data. Now, I don't know it's going to be an outlier, but if you look, 10.2 definitely jumps up to 14.1, doesn't it? Okay, so finding an outlier is just a series of, we have to answer a couple questions. First of all, what's the interquartile range? Well, we would find the interquartile range by taking what? 14.9 Q3 minus 14.4, and what do we get? 0.5. Then this says 1.5 IQR. That means take 1.5 times the IQR. So we're going to take 1.5 times 0.5. And what do you get? Bless you. You get 0.75. No, I know. Okay, what we're doing, and we call this 1.5 IQR the magic number. Okay, it's something that it's a rule. It's 1.5 times the IQR, and that tells you if you're too far above or below. So take Q1. We want to know if there's a number that's too small. So Q1 is 14.4, right? Take 14.4 and subtract 0.75. And what do you get?
7.1.
No. You're taking 14.4 minus 0.75. I have 13.65. Can someone confirm this? Anybody confirm that?
Yeah.
You didn't do it. Okay. That means if there's any numbers lower than 13.65, it's an outlier. This is like your cutoff. Do you see what I'm telling you? So quartile 1, if you think about what your plot would look like, quartile 1's here. And if there's anything too low, it's sort of, we're looking to see if there's anything too far above or below the 50% of data in the middle. So that's why we take quartile 1 and we take away that magic number. It was 1.5 IQR. Are there any numbers less than 13.65? Yeah, the 10.2. So we're going to throw that out. That's now going to be an outlier, and we mark it with an asterisk. So you can't completely get rid of it. It has to be represented, but it's not going to be part of our graph. It will be an asterisk on the graph. What's my new minimum? 14.1. Okay, now we're going to look and see if there's anything too high. So take Q3, which is 14.9, and add 1.5 IQR, which is 0.75. So you take away from the lower quartile, and you add to the upper quartile to see if there's anything too high above it. And this gives me, I have 15.65. Can anyone confirm that?
Yeah.
Are there any numbers greater than 15.65? Yeah, 15.9 and? So again, we're going to mark these with an asterisk. So my lower outlier is not 13.65. My lower outlier is anything below that, which is 10.2. My upper outliers are anything above this cutoff. So this is not an outlier, this is my cutoff. So I'd put here, I have 2 upper outliers, 15.9 and 16.4. So we need to make, throw out my maximum. What's my new maximum? 15.1. Well, remember, these are just my tests, so I'm not using them on the graph. I'm going to start at my original low, which was 10, 11, here's 12. I'm going to count by ones, but show every two.
Why'd you put 15?
Yeah.
I don't know. 16. Is this supposed to be 18? 20? Is that better?
10, 12, 14,
I just,
16, 18,
I get
20.
carried away. Okay. Put an asterisk about 10.2. Remember, it's not quite at 10, it's 10.2. Put an asterisk at 16.4. I went way too high. So that's 17. 16.4, put an asterisk. Put an asterisk at 15.9, so right in front of that. And then we're going to make our box plot using our new minimum of 14.1. Man, this is going to be really small. I have a quartile 1 at 14.4. I have a median at 14.6. I have Q3 at 14.9. Remember, this is 15. I should have stretched this out. And I have one at 15.1. So that is my box and whisker plot. So instead of having this whisker go the whole way down, there are no points in between here, so this is considered an outlier. I think I have a better box and whisker plot. I stretched it out a little bit more. You can see a little bit better there. So if you're asked for a modified box and whisker plot, that means you're finding the outliers. If it doesn't say anything about modified or outliers, then you're just going to do a regular box and whisker plot. If there are no outliers, you would have your regular box plot and you would just say no outliers. Okay? I don't need you to memorize this, but you should understand how to get. So if I say I need the 5-number summary, you should understand how to find this. If you're given these rules, you should be able to find that outliers by going through these steps.